This is CCEA Maths past paper, so this one is M8 paper 1. It's a non-calculator one, and it's from November 2021. Let's look then at question 1. So we have an inequality here. We have 2x minus 1 is less than or equal to minus 5. So I would want to add 1 to both sides, and that gives me 2x less than or equal to minus 4. Be careful there whenever you're adding 1 to minus 5, obviously. Then we want to divide by 2, and I would give me then x is less than or equal to minus 2. Show your solution on the number line. So less than or equal to minus 2, that means we colour in the dot because that number is allowed, and then my wee arrow then kind of heads left that direction there. So that's it on the number line. Question 2. A spinner has sections labelled A, B, C and D. The spinner is spun and the relative frequency of landing on D is recorded every 10 spins. Some of the results are recorded in the table below. And we have that. After 50 spins, so this is this one here we're missing, the spinner has landed in D 19 times. Fill in the relative frequency. So that's going to be 19 over 50. And that's the same then obviously as 38 over 100, and for a decimal here then it's going to be 0.38. How many times had the spinner landed in D after 60 spins? So that's 0.45, so that's the same as 45 over 100. If we divide those by 5, we would get 9 over 20. And then we're trying to work out then for 60 spins, so that's times by 3, so we times that by 3, and so it would be 27. Do you think the spinner is biased? Give a reason for your answer. Well, if we look at the wee spinner here, and this is the amount of time it's coming D, it looks like a square, so I would expect for it to be a quarter for each of those, 0.25, but it's way higher than that. So I do think it's biased. Yes. Because I would expect D to have a relative frequency of 0.25. If this spinner is spun 400 times, how many times would you expect it to land on D? Well, we take our best piece of information there and 0.45. So it's effectively 0.45 times 400. You can either think about it's 45 over 100 and you times by 4, or you can, two decimal places bring us up to 45, but either way it's 4 times 45, which is an easy one. 2 45s are 90, and times that by 2 again, and we have 180. Question 3. Use graphs to solve the simultaneous equations y equals 2x plus 1 and y equals 10 minus x. The graph of y equals 2x plus 1 has already been drawn for you. You can draw this graph a couple of different ways. You could go the old basic way of just kind of making out a wee table where you have x and y, 0, 1, 2, 3, 4, and work out what x is and work out what y is from there. What I'm going to do, however, is just use y equals mx plus c. So I know my y-intercept here is going to be at 10, so it goes here. And a gradient then minus x means the gradient must be minus 1. So that means every time I go along 1, I go down 1, like this. And I can join my points in from there. The question is asked us to solve the graph simultaneously, so we're just trying to find this point here where the two lines cross each other. So that's a x coordinate of 3 and a y coordinate of 7. So x is 3 and y is 7. Question 4. On the grid, reflect shape S and the line y equals x. This is a bit like our straight line graphs again. Y equals x, you can either think about as the x coordinates and the y coordinates are the same. So the point 1, 1, 2, 2, 3, 3, 4, 4. Or for y equals mx plus c, the gradient's 1 and the y-intercept 0. So across 1, up 1, and so on. Either way, our line looks like this, going through here. So there's the line y was x, and we need to reflect it then on that. So we kind of do, some people like to turn it like this, and they kind of see it going across from there, but it's kind of our working lines here. If we do perpendicular working lines perpendicular from the line of reflection, that's half a square away. Hope you can see that. So that's going to be equivalent point out here. Again, this here, 1.5 squares. So that's 1.5. That's 2 squares. So we go 2 there. This point here is 1, 2, 3 and a half. So there's a half, 1, 2, 3. And then this point here, 1, 2. That's 1, 2. So you can see the new shape. Nice thick lines so that we can see them okay. And that's our reflected shape. Andy and Zoe have the same rates of pay. Andy worked 12 hours normal time and 8 hours overtime and earned 238. So we worked 10 hours normal time and 15 hours overtime and earned 315. Calculate the rates of pay for normal time and overtime. So this is going to be simultaneous equations. We're not allowed to guess. So I'm going to let the normal time be x and the overtime be y. And I can come up then with my two equations. So it's going to be 12x plus 8y is 238, and then 10x plus 15y is 315. There's a couple of different ways of solving these. You can make the 8, 15 the same, you can make the 10 and the 12 the same, but I'm actually going to cancel them down a bit and just kind of make my numbers a bit more straightforward. This one here divides by, well, it divides by 2 anyway, so it's going to be 6x plus 4y. Half of 30 is 19, so it's going to be 119. Call that equation 1. This one divides by 5, so it'll be 2x plus 3y. And dividing that by 5, just be careful, I suppose. Goes in 6 times 1 left over, so it's 63. And that's equation 2. So what am I going to do? I'm now going to make the x's the same. So I'm going to times this one then by 3. So it's equation 2 times by 3 gives me 6x plus 9y times up by 3. 3 60s are 180, so 189. And then equation 1 is 6x plus 4y is 119. And then I subtract those, so they disappear. That then gives me 5y, and that's 70. That means y is going to be 14. Substitute this into anything. The easiest one really looking there is that one. So I'm going to substitute back into number 2. 2x plus 3y is 63. 2x, 3 14s are 42. Is 63. 2x, 42 take away 63 is 21. So x then is 10.5. X was my normal, so it's £10.50. It's a 10.5 obviously, and then my overtime, y was 14. Question 6. 1 million centimeters cubed of gas has a mass of 1.5 times 10 to the power 4. Given your answer in standard form, calculate the mass of 1 cubic centimeter of the gas. Well, we need to divide this by a million effectively. So it's 1.5 times 10 to the power 4 divided by, and if we just write it, you write it as 1 times 10 to the power 6, but this 10 to the power 6 makes it straightforward. 10 to the power 4 divided by 10 to the power 6, we subtract those two powers, so 4 take away 6 then gives us -2, and that's our answer. So it's 1.5 times 10 to the -2. Change this here into a fraction, so it's 0.0858585, so we want to let that equal x. or then find out 100x. So 100x is going to be 8.58585 dot dot dot. X is 0.08585 dot dot dot. So if we subtract those, we get 99x. This take away this gives me 8. This take away this gives me this, and then all these cancel each other out. That's kind of the idea. So that means x is 8.5 over 99, which is 85 over 990, and then we need to divide both of those by 5. So that's 17, and you just 990 divided by 5. Do it again whatever way you want. There's nothing wrong with doing something like this. 149, and that goes 9 with 4 left over and 8. So 17 over 198. Then as our final answer with it cancelled down. Question 8. The probability that Joe will be late for work on any Monday is 0.3. If Joe is late on work on Monday, the probability she'll be late on Tuesday is 0.1. If Joe is not late on Monday, the probability she'll be late on Tuesday is 0.3. Draw a tree diagram to show this information. So this is going to be our Monday. And then late. And then I suppose not late. Late in work for Monday is 0.3. And then this would be 0.7, taking that away from 1. Tuesday is here, late, and not late, late, and not late. If Joe was late on Monday, so that's that one, probably late on Tuesday, then it's 0.1. And that makes this 0.9. If she's not late on Monday, probably she'll be late on Tuesday, is 0.3. And then 0.7. So that's me done there. Using the tree diagram, use the tree diagram to work out the probability that Joe is late on Monday or Tuesday, but not both. So that would be that one there and that one there. I hope that makes sense. So 0.3 times 0.9, be careful here, gives me 0.27. And 0.7, 0.3 gives me 0.21. So it's going to be 0.27 plus 0.21, and that gives me 0.48. The 0.23 lies on the circumference of x squared plus y squared equals a squared. Work out the value of a, giving your answer in surd form. Okay, so that's your x coordinate and that's your y coordinate. So we should be able to work out then from there. So 2 squared plus 3 squared equals a squared. 4 plus 9 is a squared. A squared is 13, and so then a is the square root of 13. If that makes sense. Work out the equation of the tangent to this circle at the point P. So let's have a wee think about this then. So we have our circle. It's at the point 2, 3. And we're trying to find then the equation of that. The gradient of the radius. So let's think. There's 0, 0. This isn't getting too complicated for you. And there's 2, 3. So if we want the gradient of that, that's 2 and that's 3. So if we go for gradient of radius is 3 over 2, then gradient of the tangent must equal minus 2 over 3. Do you see what I've done there? Because it's the negative reciprocal. Okay, So that means it's y equals mx plus c. Y is minus 2/3 x plus c. And we know the point 2, 3 is on this. So 3 equals minus 2/3 upon 2 plus c. Running out of space here, but that's okay. 3 is minus 4 over 3 plus c. So I add that and I get then 4 1/3. C is 4 1/3, or if you want 13 over 3. So my equation then of the tangent is y equals minus 2/3 x plus 13 over 3. Work out the equation of the other tangent to this circle, which is parallel to the tangent at P. Okay, so it's going to be this one here, and it's going to be then this point here. So what's that coordinate there? That's going to be the coordinate minus 2, minus 3, which is going to be on it. And so we just do the same thing. It's the same gradient, obviously. So it's y equals minus 2/3 x plus c, minus 3 equals minus 4 over 3 plus c. I hope you're okay with that. Let me see. Oh, sorry, it's plus. That's a plus. 4 over 3 plus c, because you're timesing it then by the minus 2. So if I take away 4 over 3 from both sides, then c is then minus 13 over 3. So that's pretty much us. So our line then is going to be y equals minus 2/3 x minus 13 over 3. Faradays's rule 3 times. What's the probability of getting a 6 exactly once? So there's a couple of different ways of doing this. So we can kind of do a tree diagram and kind of think about how the 6's are going to work out. It's either a 6 or not a 6. So we'd have a 6 or not a 6, a 6 or not a 6. And then they work out then from there, but the probabilities are always the same. So you would have to go 6, not a 6, not a 6, or not a 6, 6, not a 6, or not a 6, not a 6, 6. So what are your probabilities here? It's going to be a 6 times 5/6 times 5/6, and these three are just going to be the same. So it's just going to be 3 times that. So 1 times 5 times 5, I guess times 3 is 75. 6 times 6 times 6 is 216. They both divide by 3. I'll give you 25 over 72. So 25 over 72. Then is our answer then to that. Work out the values of A and B. So root 2 or 3b equals 3 times 2a to the 3. So let's write these out and kind of tidy them up a bit. So if I rearrange this one, that's going to be 3 to the minus b multiplied by 2 to the power of a half. I hope that makes sense. Do you see where that's come? So I've taken the 3b up to the top and changed the power then to minus, and that equals 3 times 2a cubed. So that's 2 then to the power of 3a. So in this case there, that's a 1. So that means that minus b is 1, which gives me that b is minus 1. And then a half equals 3a. So that means a is a sixth. And that's us. Show that cos x plus tan x is 11 root 5 over 15. Goodness me. Okay, so for cos x and tan x, we're going to have to try and find this here. So we're going to need to do Pythagoras first of all. So it's going to be, let's call this, I suppose, A and B and C first of all for Pythagoras. So A squared plus B squared equals C squared. A squared plus 4 equals 9. So A squared is 5 and A then is root 5. So that means we can have a root 5 then for there. Next we want to go OA and H. So that's O, that's A, and that's H. And we know cos x is A over H. So it's root 5 over 3. And then tan x is O over A. So it's 2 over root 5. So we need to add those two things together. Cos x plus tan x. So root 5 over 3 plus 2 over root 5. I'm going to first of all rationalize the denominator here. So that gives me root 5 over 3 plus 2 root 5 over 5. You see what I've done? I've times top and bottom by the square root of 5. Now to find the common denominator. So I would times this one then by 5. So it's 5 root 5 over 15 plus times and top and bottom of this one by 3. 6 root 5 over 15, and that gives me 11 root 5 over 15, which is what they wanted.